This is Math 1314, College Algebra. We're going to go finish up section 1.7, which deals with inequality equations, and then we'll do section 1.8, which is on absolute values and inequalities. I'm David Dipple from Lone Star College, Montgomery. Suppose you have a quadratic inequality, such as x squared plus 3x minus 24 greater than 4. The first thing you do, it has to have a 0 on the right side, so we move the 4 over, and we get 28. 24 minus 4 is negative 28. 7 times 4 makes 28, so we factor that. And you'll notice I went from a greater than to an equal. And you cannot graph a greater than. You don't know which way it's going to go. So what you have to do is graph equal on a number line and then test the intervals. When you factor that, you get x is negative 7 and positive 4. So we'll put those on a number line, and since there's no actual equal sign under the greater than symbol, we'll put circles around them. So we have negative 7 with a circle and positive 4 with a circle. Then we check the interval over here. We plug in negative 8 into the factored form and assume, again, this is back to our greater than. So negative 8 plus 7, from right here, negative 8 minus 4, greater than 0. This is negative 1 times negative 12. That would be positive, which is greater than 0, which is true, so I shaded it. Then I pick a number in the middle, which would be 0. 0 plus 7, 0 minus 4, greater than, again, we go up here, greater than 0. So we get 7 times negative 4 is a negative number. If that's bigger than 0, that is false. So again, I don't shade it. And then I pick a number bigger than 4, like 5. 5 plus 7, I put it in the factored part. 5 minus 4, this is 12. 5 minus 4 is 1. 12 times 1 is bigger than. Again, I use the greater than symbol that we started with, and greater than 0, which is true, so I shaded it. So if we go to intervals, I have negative infinity to negative 7, and from 4 to infinity. So it's negative infinity to negative 7, both getting parentheses because there's no equals, and from 4 to infinity. Okay, suppose we have a rational inequality, a fraction. You'll take the top, and you take the bottom, and you put all those numbers on a number line. So you factor the top. That gives you negative 2, positive 2, and positive 1. The positive 1 is a not equal, and the other two, since there's an equal sign under it, they're going to be equals. So we put all those on a number line. So we have negative 2 with a solid circle. 1 came from the denominator, so it gets an open circle. And then 2, again, because it's equal, because it came from the top, it gets a solid circle. Then we check all these intervals, plug in negative 3 into this factored form right here, and you go back to the less than or equal to. You can go back to the original if you want to. I usually go back to the factored form. If I plug in negative 3, this turns out to be negative, this turns out to be negative, and that turns out to be negative. So 3 negative numbers is less than 0. That's true. Okay, then I pick a number between negative 2 and 1, which would be 0. Okay, if I plug in 0, this is positive. 0 minus 2 is negative. That's negative. So this whole function is positive, because we have two negatives. So this is positive. Negative 4, negative 1, if you want to plug zeros in here. Less than 0, that's false, so I don't shade it. Between 1 and 2, pick like 1.5. If you go in the factored form, it's easier. 1.5 plus 2 is positive. 1.5 minus 2 is negative. 1.5 minus 1 is positive, so this whole thing is negative. Negative is less than 0, that's true, so I should shade it. And then if I plug in 3, 3 plus 2 is positive, 3 minus 2 is positive, 3 minus 1 is positive. This is all positive. A positive number is not less than 0, so it's false. So then if you look what you graphed, we have negative infinity to 2, we have 1 to 2. So that would be our intervals. Negative infinity to 2, 2 gets a bracket because it's included, union with 1 to 2. 1 does not get included because it came from the denominator. Came from the bottom. It can't be 0. And then 2. Okay, absolute values. In section 8, we deal with those. You copy this equation 2 times. You throw away the absolute value. One, you copy it exactly. So it's x minus 3 equals 8. And you leave what's on the inside. Then the second time you copy it, you change what's on the inside. Negative x plus 3 is equal to 8. A lot of places will change the right side. I prefer to change the inside because that's the definition. The inside is either plus or minus, and the outside is always positive. So it's safer if you will change the inside. So we leave the inside alone, and then we change everything on the inside. So we solve this, add 3, and get x is 11. Subtract 3, and then divide by -1. Gives you -5. So those are our two solutions. X is 11 and x is -5. Now we can do the same thing with inequalities. You just take the whole thing, make it equal to 9, change the inside, equal to 9. And again, since it's an inequality, we put it on a number line and check it rather than trying to assume greater than and less than and all that. It's much faster. So we leave it. 2x plus 5 equals 9. Then we change the inside. Take whatever's on the inside and I change it. -2 minus 5 equals 9. Then we solve this. Subtract 5, divide by 2, and get x equals 2. Okay, add 5, you get 14, divided by 2 is -7. And I put those on the number line. So I put -7 and +2 on the number line. Those should both be actually colored in because of the equal sign. Okay, if you plug in -8, I go back to the original. -8 doubled is -16 plus 5 is 11. Its absolute value is bigger than 9. That's true. I'm going to plug in 0. 0 plus 5 is bigger than 9. That's false, so I don't shade it. And the 3, 6 plus 5 is 11. Is bigger than 9. That's true, so I shade it. So again, these should be colored in because it's an equal sign. And so I should have -infinity to 7 with a bracket because again it should be colored in. And then 2 to infinity gets a bracket. And again, these should be colored in. Okay, the final one we're going to do. Now that was it. We've already dealt with those. So absolute value inequalities, just write them down twice and graph them and find the answer.